In this media, we are going to discuss about the backlash and all the technical aspect and how we do calculation of these things. So what is more important to know here is that we have already covered all the gear terminologies and the gear aspect, types of gear, bevel gear, spur gear in the part 1 of this video. So before watching this video, please make sure that you watch that video. So here we'll see the formula aspect and all, and what all we use in the calculations for this gear. So please watch the first part of the video and then we continue from there, because we have already covered there around 60 slides. Now from here we'll continue on to more maybe odd 42 slides. Okay, so when we speak about backlash, so you must be knowing that backlash in gears refers to the amount of play or clearance between the teeth of mating surface. Okay, so it is the amount of clearance that we have between the mating gears. It's the distance between the tooth flank when they are in mesh. This lost motion can occur due to manufacturing tolerance, wear or misalignment. So there can be a different reason because of which the backlash can be there. So that is a separate aspect. So we'll move further. So you must have seen we have already covered the gear terminologies also in the first part of the video. In the addendum, dedendum, what are all these things are there. Now when we speak about line of action and pressure angle, so we'll define on the terms whatever we covered in the first part of the video in the gear terminologies. Okay, apart from the types of gear and all definition, their advantages and disadvantages. So when we speak about line of action, line tangent to both base circles. Okay, so that is line of action. So you see here it is already depicted here, line of action. Now pressure angle, angle between the line normal to the line of center and the line of action. Okay, so now pitch point, when we speak about it, is the intersection of line of centers with the line of action. So pitch circle is this. Now see, addendum, we have addendum circle, we have dedendum, and then we have dedendum circle. Then we have pitch circle. Now mark position A and B on the addendum and base circle. So what we'll do is we'll mark the position A and B on the addendum and base circle. Okay, we have now marked. Now divide the distance AB into 3 equal parts. Now we'll divide distance AB in 3 equal parts. Okay, AC is equal to CB. Now AC will be equal to CB. Okay, so this is there that AC will be equal to your CB, and then what we divide, what we are going to see from here, that this your line from C, draw a tangent to the base circle. From C we are going to draw, and this gives the point D. So when we draw the divide CD into 4 equal parts, that is DC is equal to 3EC. So DE is equal to 3EC. Having got the point F, draw an arc from E through C and the addendum circle to the dedendum circle. Draw in the fillet radius to complete this part. Okay. Now, relationship between pitch and base circle. So when we speak about the relationship between pitch and the base circle, now you see here, this is the pitch. Okay, and this is your base circle. Now when we speak about this angle, so it is RB is equal to R cos phi. So that is the whole relation altogether that is given. Now pitch cylinder, two imaginary friction cylinders that can transmit same amount of power by virtue of surface roughness as that of gear drives, are called pitch cylinders. Now pitch surface, the surface of the imaginary rolling cylinder. Now the surface of the imaginary rolling cylinder. Pitch circle, a right section of the pitch surface. Now the pitch circle is that a right section of the pitch surface. Pitch circle diameter. Diameter of pitch circle is called pitch circle diameter. Now pitch point P, point of intersection of pitch circle. Now this is the point of intersection of pitch circle. Circular pitch PC is the distance from a point on one tooth to the corresponding point on the next tooth measured around the pitch circle. Now PC is equal to pi d by t is equal to pi, that is small d by t for the smaller one. So the module is equal to, module is ratio of PCD to number of teeth. So please remember this, the module is ratio of PCD, that is pitch circle diameter, to the number of teeth. M is equal to D by T is equal to small d by t for a bigger circle and for the smaller. Diameter pitch PD, ratio of number of teeth to PCD, that is T by D is equal to small t by t. The addendum circle is that which contains the top of the teeth and its diameter is the outside or the blank diameter. The dedendum or the root circle, dedendum is also known as the root circle, is that which contains the bottom of the tooth spaces and its diameter is the root diameter. Now addendum, now we discussed the radial distance between the pitch circle and the addendum circle. So that is the radium distance. So we can see here in the diagram altogether. If you want to see, I will just show you addendum and dedendum. It was clearly mentioned there, though we have covered in the first part of the video, but still. So you can see here we have addendum, dedendum, okay, addendum circle and a dedendum circle. So it is clear from here. Now we'll move on to our slide. Okay, the radial distance between the pitch circle and the addendum circle, addendum is equal to 1 module. So we have already covered what is the module. Module is the ratio of PCD to number of teeth. Okay, now when we speak about addendum, the radial distance between the pitch circle and the root circle, pitch circle and the root circle, that is dedendum. So dedendum is equal to 1.25 times the module, that is addendum is equal to 1 module and this is dedendum is 1.25 times of the module. Now clearance, radial clearance, the difference between the dedendum of one gear and the addendum of the mating gear. So that is the difference between the dedendum of one gear and the addendum of the mating gear. Now when we speak about clearance, that is dedendum minus addendum. So that will give your clearance. Tooth width, the thickness of the tooth measured on the pitch circle. So that is the thickness of the tooth measured on the pitch circle. This is important, where you are taking the measure of the, because the tooth has got different dimension altogether from its base to the top. Tooth space, the distance between adjacent teeth measured on the pitch circle. Backlash, it is also known as circumferential clearance, the difference between the clear circle thickness of one gear and the tooth space of the mating gear. Backlash is equal to tooth space minus tooth width. The whole depth, that is total depth of a tooth is the sum of the addendum and the dedendum. The working depth of a tooth is the maximum depth that the tooth extends into the tooth space of a mating gear. It is the sum of the addenda of the gear. So it is the sum of the. Now the pressure angle that we have seen, the angle between the line of action and the common tangent to the pitch circle at the pitch point of the pressure angle. So this is the, you can see here, this is the common tangent that was there, that was your pitch circle, and this is the green one is your line of action. Okay, so there you can see it. Fillet, the small radius that connects the profile of a tooth to the root circle, the small radius that connects the profile of a tooth to the root circle. Pinion, the smaller of any pair of mating gears, the larger of the pair is called simply the gear. Top land, it is the surface on the top of the tooth. Bottom land, it is the surface between the two teeth. Base circle, it is the circle from which involute profile begins. The tooth face is the surface of a tooth above the pitch circle parallel to the axis of the gear. The tooth flank is the tooth surface below the pitch circle parallel to the axis of the gear. If any part of the flank extends inside the base circle, it cannot have involute form. It may have it is any A and T it is written. It may have any other form which does not interfere with mating teeth and is usually a straight radial line. The line of action, contact between the teeth of meshing gears takes place along a line tangential to the two base circle. This line passes through the pitch point and is called the line of action. Path of contact, it is the path traced by the point of contact between the two teeth from the beginning to end of the engagement. Length of path of contact, it is the length of the common normal intercepted between beginning of the engagement and the end of the engagement. Length of path of approach, it is the length of the common normal intercepted between beginning of the engagement and the pitch point. Length of path of recess, it is the length of the common normal intercepted between pitch point and the end of the engagement. Arc of contact, it is the path traced by a point on the pitch circle from the beginning of the engagement and at the end of the engagement. Arc of approach, it is the path traced by the point on the pitch circle from the beginning of the engagement and the pitch point. Arc of recess, it is the path traced by the point on the pitch circle from the pitch point and the end of the engagement. So though it is just I just gone through because we have already seen in the diagram in the first part of the video. Standard tooth system. Okay, so this is, you can see the as per pressure angle what is there and what is the addendum and what is the dedendum, full depth and for the stub piece. Okay, now conjugate action or law of gearing. So now we'll consider this. Now these are the two bodies. Okay, two rigid bodies, and now we'll see, consider two rigid bodies, 1 and body and 2, which rotate about fixed center O1 and O2. You can see here E is O1 and O2. Okay, in the diagram altogether, O1 and O2. Okay, with angle of velocity omega 1 and omega 2. So this we have what is known as your angle of velocity, that is your omega 1 and omega 2. The bodies touch at the contact point C. Now the body is touching at the contact point, this is the contact point, that is your C, through which the common tangent and the normal are drawn. So there is a common tangent and the normal which is being drawn. You can see here. The absolute velocity v of the contact point reckoned as a point on the either body is perpendicular to the radius from that body's center O to the contact point. For the bodies to remain in contact, there must be no component of relative motion along the common normal, so that form of the velocity triangle where v2 cos theta 2 is equal to vn cos theta 1 and v1 is equal to omega 1 into O1c and v2 is equal to omega 2 into O2c. So that is the whole derivation altogether. So you can see also here, so we have derived what is known as for similar triangles. We have drawn two triangles here, you can see, across the tangents, and then we have come to the conclusion that omega 1 by omega 2 is equal to O2p by O1p. Okay, now conjugate or the law of gearing. Law of gearing states that to obtain a constant velocity ratio, a common normal drawn at any point of contact between two mating teeth in between beginning of tooth engagement till end of the tooth must pass through a fixed point known as pitch point, which is always located on the line joining the centers of rotation of the gear. Okay, so this is your law of gearing or the conjugate action, that is omega 1 by omega 2 is equal to O2p by O1p. Velocity of sliding of the teeth. The velocity of sliding is the velocity of one tooth relative to the other along the common tangent at the point of contact. Components of velocity of sliding of tooth surface along common tangent are v2 sin theta 2, v1 sin theta 1. Velocity of sliding of tooth surface 2 with respect to 1 at that point of contact is given by vs is equal to v2 sin theta 2 into v1 sin theta 1. Vs is equal to omega 2 into O2c into C2c by O2c into omega 1 into O1c into C1c by O1c. So Vs will come out to be omega 2 into this derivation will come out, and then we will subtract the first part from it. So you can see here what we have gone is that Vs is equal to omega 1 plus omega 2 into Cp. So that is the velocity of sliding is the product of algebraic sum of the angular velocities and the distance of point from pitch point. So distance of point from the pitch point, that is velocity of sliding. Now we have draw a small curve, divide the circle into 12 sectors, draw a line perpendicular to AO and from the L intersect the line at the point number 1. Repeat the process from A to L, drawing the curve from 0 to 12, then drawing the involute of the circle. So that will be the involute of the circle that we are trying to rotate. So you can see here. Now cycloids. So when we speak about cycloids, a cycloid is the path or locus of a point on the circumference of a circle which rolls without slipping along a straight line. Imagine a bicycle wheel with only one spoke rolling along the straight line. If the path of the end of the spoke was traced as the wheel rolls along, this path would be a cycloid and is shown below. So that is your cycloid that we were speaking about. Okay. Now epicloid and hypocloid. So what we will discuss now is the epicloid and hypocloid. So generation of an involute by a knotted taut cord unwinding from a base circle. So generation of an involute by a knotted taut cord unwinding from a base circle. Comparison of cycloid and involute tooth forms. So involute gears, so this is the important difference between them. Involute gears in mesh gives conjugate action. Cycloid gears in mesh gives conjugate action. The profile of involute gears in the single curvature, which is involute. The profile of cycloid gear in the double curvature, which is combination of epicloid and hypocloid. The line of action of path of contact is straight line. The line of action of path of contact is curvilinear. So the pressure angle is constant at each point of contact. The pressure angle varies at each point of contact. Basic rack for involute tooth profile has straight line form. Basic rack for cycloid tooth is formed by part of cycloid curve. Involute gears are not sensitive to the center distance variation, hence variation in CD is permitted up to certain limit to transmit constant angular velocity ratio. Cycloid gears are sensitive to the center distance variation, hence it is not allowed, otherwise it will affect on VR. Suitable for motion as well as power transmission. Suitable for only motion transmission. Involute gears do have interference and problems thereof. Cycloid gears do not have interference and problems thereof. Manufacturing is easy due to single curvature. Manufacturing is not easy due to double curvature. Standard involute tooth is weaker than a cycloid tooth due to radial flanks. A cycloid tooth is stronger than a standard involute tooth due to spreading flanks. So involute tooth have more sliding action and hence more wear due to rubbing. Cycloid teeth have less sliding action and hence less wear due to rubbing. It is not possible to have low number of teeth in case of standard involuting toothing system. It is possible to have low number of teeth as low as 6 or 7 in the cycloid system. So length of path of contact when we speak about, so this is there, the base circle of wheel, pitch circle of the wheel, addendum circle of the wheel. So when we speak about addendum circle of the pinion, pitch circle of the pinion, base circle of the pinion, you can see the pressure angle. So these are the derivation that is important, so you can just go through it. So that is the last derivation that we got it from here. Length of arc of contact. The arc of contact is the path traced by a point on the pitch circle from the beginning to the end of the engagement of two meshing teeth. Okay, so that is there. So length of arc of the contact. So you can see from here all these aspects. Now contact ratio. We have already seen which gears have more contact ratio. All these things. So CR is equal to 1.2 length of arc to the contact by PC. Length of arc of contact is equal to 1.2 times PC. By the definition of circle pitch arc 1A 1B is equal to PC. The contact arc 1A 2B is equal to arc of contact. This means for 20% of the cycle two teeth would be in contact and for 80% of the cycle one tooth would be in contact. So that is the normal definition. Formulae for the gear. N1 by N2 is equal to G omega 1 by omega 2 is equal to T by T is equal to R by D is equal to D by D is equal to gear ratio. So that is the law of gearing is equal to omega 1 by omega 2 is equal to O2P by O1P. We have already derived it in the previous slides. Sliding velocity where Kp is equal to distance of contact from the point, pitch point. Okay, omega 1 plus omega 2 by Kp, and then rolling velocity is equal to Vr is equal to R omega 1 is equal to R omega 2. Okay. Length of path of approach, length of path of recess, length of arc of contact. So all these formulas we have to remember for solving the question. Maximum possible length of approach, maximum possible length of recess, maximum possible length of path of contact, the involute gears. So that is there. Critical minimum number of teeth to avoid interference. So that is also there. And then pitch circle, addendum circle, and then we have undercutting. Therefore, the profile of tooth below the base circle is non-involute. So why it is non-involute? That is there. In this case, the profile of wheel and the pinion will be tangent to each other, and the tip of the wheel will dig out or interfere with the flank of the pinion and remove the part of the material called undercut, and process of removal of material is called undercutting. So there is an undercut that is available there. So this phenomena is occurring. So you can go through the video. My idea was to bring the contact this text under one umbrella, so you can have a look and pause the video, and based on that you can decide what you want to do or not. Okay, so all the definitions we have already covered. Types of gear, first of part of the video, that is more important. Then you can move on to the second part of the video. We have covered all the gear terminologies, all the ratios. Okay, gear law of gearing, that also we have covered. I hope it is clear for you. Thank you so much. Thank you for your valuable time. All the very best.